Dion has 26 meters of wire fencing to make a rectangular pen for his 2 show lambs. He has learned that each lamb should have 20 meters squared of space. Does he have enough fencing for an area of 40 meters squared? Use a table to determine your answer. Okay, so using what we have, we know that he has 26 meters of wire fencing. And so if he has a rectangular pen, then that basically just means the fencing would be the perimeter. And so adding up, the width each side and then the length each side, that will equal 26. So we could say 2L plus 2W equals 26. And then we also want to know, will the length times the width, or the area, will that equal 40? And so we can't do much when we have 2 separate variables like this, but if we could get our area equation into just one variable, then we would actually be able to solve and figure out if it equals to 40. And so to get it into one variable, we just need to we could use our first equation and solve for either L or W. Let's just go ahead and solve for L, and we'll make this area equation all in terms of W. So solving for L, we could subtract 2W on each side. So we get 26 minus 2W equals 2L. And then we can divide by 2 on each side. So we get 26 minus 2W divided by 2 equals L. So then we can just take this and substitute it right into our area. And so then it would be 26 minus 2W divided by 2 times W. And then simplifying this out, then 26 divided by 2 is just 13. 2W divided by 2 is just W, so that would be minus W times W. And then we could distribute, so 13 times W is 13W, and negative W times W is negative W squared. And then this would be a function now, since we have it all in one variable with a quadratic, so be A of W equals 13W minus W squared. Now we can just see, using a table, will A of W ever equal 40 if we plug in different widths W? And so the related equation would be 40 equals 13W minus W squared. So let's go ahead and bring up a table. And I've already filled in here the width of the pen, W, and just all the different widths here, starting at 0, and then we're going to figure out what's the area of the pen, A of W. And we can do that just by substituting in the W value into our function. And so if we put in 0, 13 times 0 is just 0, minus 0, well, that's just 0. Plugging in 1, 13 times 1 is 13, minus 1 squared is just minus 1. So 13 minus 1 is 12. 13 times 2 is 26, minus 2 squared, well, that's minus 4. So 26 minus 4 is 22, and so on. We'll just go ahead and plug in each of these W values. Okay, so we see from our table that it does reach 42 times when the width is 5, and also when the width is 8. And so then our answer would be, well, the width could be 5, which would make the length, well, the length, remember, is 13 minus W simplified. So the length then would be 13 minus 5, which is 8. So we could have a width of 5, length of 8, or vice versa, a width of 8, and then 13 minus 8 is 5, so length of 5. And so let's go ahead and summarize our answer. Let W stand for the width of the pen. Since the perimeter of 26 is twice the length plus twice the width, 26 equals 2L plus 2W. Twice the length is 26 meters less twice the width, 26 minus 2W. So the length is half that amount. The area of the pen then is A of W equals 26 minus 2W divided by 2 times W equals 13 minus W times W equals 13W minus W squared. The related equation is 13W minus W squared equals 40. We have our table. An area of 40 meters squared occurs when the pen is 5 meters wide and 13 minus 5 or 8 meters long, or when it is 8 meters wide and 13 minus 8 or 5 meters long. Yes, he has enough fencing.